Thank you for the introduction. As mentioned, I'm Viraj. I'm a senior software engineer on the privacy infrastructure team. And in today's talk, I'll be discussing xray, our software solution to demystifying access control in our data warehouse. A little bit of background on Cruise. We are a self-driving ride-hail and delivery service, which has currently amassed over 4 million driverless rides to date. We currently offer fared rides in California, Arizona, and Texas, and are in the process of expanding to other states. Now, in addition to the privacy challenges of a ride-hail business, Cruise vehicles also collect a lot of camera, image, and sensor data as we go on our rides, making the privacy team's job all the more important. So in today's talk, I'll first be covering the motivation for why we built this tool, a little bit about how xray works, and then finally how we have used xray to mitigate privacy risk at Cruise. So before jumping into that, a brief shout out to my colleague Mark, who has largely built our in-house data map, Indiana. Indiana was a critical component used in conjunction with xray in order to help us mitigate privacy risk. If you're interested in learning more, I highly recommend you check out his talk, which was presented at PEPR 2022. And with that, let's jump into our motivation. So our goal here is essentially least access in the data warehouse. Not only is least access required by law under CCPA and other guidelines, but at Cruise we also like to say that privacy is a product feature. Beyond just meeting our legal standards and avoiding legal risk, we also want to uphold our reputation and keep customer trust. And the way we do that is with the following three-step process. Step one is data mapping, figuring out where sensitive data is in the warehouse using our data map, Indiana. Step two is then auditing read access to sensitive data using our software solution, xray. And step three is then working with system owners and data owners to remediate instances of least access, instances of overprovisioning, basically cases that don't follow least access. So our problem statement comes down to answering two questions. Question one, who all has read access to a given resource in BigQuery? And question two, how exactly are these users getting access? What roles are they being granted? What groups are they a part of? An idea that we call lineage. So seemingly simple questions that, as we discovered, are not very simple to answer. There's a lot of complexity with cloud IAM, specifically in BigQuery, that makes this a little difficult to audit without a software solution. So we can see here on the left-hand side the resource hierarchy that exists in BigQuery. Essentially, there's an idea of organizations, projects, datasets, and tables, and permissions are additive. What that means is if I have read access to a table, I could be granted that access at the table level, or I could be inheriting it from the dataset, or from the project, or all of the above. Now in that middle column, you can see the idea of roles. A role is basically just a bundle of permissions, and in our case, we're interested in searching for the permission that grants read access. And as I mentioned before, roles can be granted at any level in the hierarchy of GCP resources. And then finally, on the right-hand side, we have this idea of principals. A principal is essentially a user or group that is granted all of the permissions associated with the role. So let's take a look at what answering our problem statement looks like without a software solution. Over here is a view of the GCP console. And you can see that if I want to figure out who all has read access for this table, I'm left with a series of questions that are pretty challenging to answer. Question one, which of these listed roles actually grants read access? In order to answer that, I would have to look at GCP documentation or make a call to one of their services to fetch a list of permissions associated with each of these roles, see which one contains the permission for read access. Second, as I mentioned before, we can see there's some groups listed on this page. I'd have to additionally look at GCP services or internal Cruise services to get a full list of users that actually make up these groups. And finally, the kicker is that the list of roles displayed in the console view is not exhaustive. At Cruise, we have other services through which roles can be added, including Terraform and an internal resource provisioning app called Juno. So all of that leads to the need for our solution. xray essentially parses that permissions tree in order to answer the two questions stated in our problem statement. And the way it does that is by first fetching IAM policy for the given BigQuery resource, as well as all parent resources, iterating through all of the roles that we find to identify the ones that include the permission for read access, unrolling any groups we encounter into a flattened set of individual users and service accounts, and then finally traversing back up the lineage of read access to identify which groups and which roles are granting access. Now, xray is primarily used at Cruise in two different fashions. The first is the ad hoc use case. So let's say as a software engineer in my daily workflow, I want to figure out all of the users that have access to some table. The way I can do that is by downloading a pip installable tool that we've released to all cruisers and then running it from terminal. So we can take a look at the example of what the output of running xray looks like. In this case, I'm running xray on a table called drives that's in the data info project. And what this output tells us is that, in this case, 3 users have read access. But as I mentioned before, it's also important for us to know where the access is coming from. So we can see here the first element here tells me what the name of the role that's granting the access is. The second element tells me at what resource is this role being granted. So even though I'm scanning the drives table, we can see that the role is being granted at the project level. Now the implication of that is that I have access to every data set and table within this project beyond just the drives table. And this third element is what I was referring to before as lineage. Now the reason this is so important is you can see that there's actually 2 fashions in which I'm granted this role. I'm part of a group called privacy engineering, which is part of a larger group that's being granted the role. But I'm also a part of a group called security engineering, which is once again in that same parent group. The reason understanding how permissions are inherited is so important is our long-term goal here is removing any cases that don't follow least access. Unless we have an understanding of how we're inheriting permissions, we don't have a straightforward path to remediation. Now, we've also integrated xray into our web app, Indiana, for our data map. This is a really handy feature because you can actually search for tables based on what sensitive data they contain, in this case, a phone number, and then xray to see the full listing of who has access. Now, the second fashion in which we use xray is as part of a daily cron job, which we run against every table that's tagged to contain sensitive customer data to generate this, the least access dashboard. At Cruise, this is our source of truth for access to customer data, and the least access dashboard has been critical in helping us identify and remediate privacy risk. And with that, we'll get into some of the wins that we've encountered in terms of mitigating privacy risk at Cruise using xray and the dashboard. Since we've released xray over a year ago, we have managed to identify and revoke org-wide read access to all service accounts at Cruise, identify and revoke eng-all read access to all projects with sensitive data, and the dashboard has allowed us to identify new instances of access and over-provisioning in basically real time, which has brought our time for remediation down from the order of weeks or months to minutes. And at the end of each quarter, we've actually managed to generate a report using the least access dashboard in order to keep ourselves, leadership, and our partner teams updated on our efforts to ensure least access across the warehouse. So I know today's talk, I've talked about our cloud solution and our software tool, but we really feel that the process, as well as some of the anti-patterns that we've identified in Cloud IAM, are applicable to privacy teams across a number of cloud solutions. Specifically, 2 of the most pervasive patterns that we identified at Cruise are the idea of umbrella permissioning and basic roles. Essentially, really large roles that contain thousands of permissions that grant a lot of access that isn't necessary. What we found is that in the early days of Cruise, when we were in R&D mode and not yet moving towards commercialization, project managers would be likely to grant engineers on their team wide-arching roles that included a lot of permissions, just to not hamper engineering productivity. Basically, the idea was the roles would cover all cases, hence the term umbrella. And similar fashion with basic roles. Basic roles existed in GCP before the formalization of Cloud IAM and include a lot of permissions that are inherited in sometimes not so obvious ways. Now, the 2 issues with these types of roles is when those projects later come to contain sensitive data or customer data, you have a large number of folks with access. And more importantly, it's extremely difficult to delete or remediate these roles because you'd have to identify what permissions included in them are relevant for actual use and which ones are extraneous. And so all of that leads to our conclusion and our most critical takeaways from these efforts. As I just mentioned, the transition from R&D mode to commercialization is likely to pose privacy risk as largely liberally granted roles will now grant access to sensitive data. We've managed to combat this problem with the 3-step approach of data mapping, auditing access to sensitive data, and then remediating over-provisioned access. And finally, that the complexity of Cloud IAM makes it pretty challenging to answer these questions and achieve least access without a software solution. Thank you for listening to my talk, and happy to answer any questions.